Hello everyone. My name is Sarthak, and in today's video, I would be basically explaining what low latency APIs are and why they are necessary and how we can make our APIs low latency. Low latency APIs are one of the most important aspects of building scalable systems, right? Basically, a scalable system is a system which can handle many users concurrently and can provide a good user experience. So that's what I mean by a scalable system, right? So if your API is slow, your entire product feels slow, and no matter how good your front end is, it basically doesn't feel good to the user, because in the end the data which is coming from the API would be displayed in the front end, right? So having slow APIs is not good for our overall user experience and also our infrastructure cost as well, which I would be explaining further, right? So in this video, I'll just break down what latency actually is, why it matters so much, and most importantly, how we can design APIs to be fast and efficient. So what is latency? Latency is simply the time taken by a system to respond to a request. So when a client sends a request to your API, latency is the total time it takes to get the response back. So if you look at the client server architecture, the total time taken by a request packet or an HTTP packet to come back as a response to the client is what we are saying to be as latency. And having a low latency system is what our objective is, right? Now, what are the types of latency? Latency can be caused due to network, the time taken for the request to travel over the internet. It could also be caused due to processing. So, the time taken by your backend to execute logic, and it could also be due to your database. So, the latency caused by database, such as the time taken to query your database and fetch all of your records or perform joins, etc. Right? So, when your API is slow, it usually is not one issue, right? But it is generally a combination of issues. Okay. Now, why does low latency matter? Why should we even care about latency? That's an important question which we should think about. So, as I said, the first point is user experience. If the user experience is not right, then the overall system is not performing well. Another point comes here is that we should take a customer centric approach or a product based mindset approach. Look, at the end of the day, the company wants that the user gets the features which they demand, or the features which are high in demand, and the user should be able to access those high demand features in an efficient and easy manner. They shouldn't face much problems or issues while trying to use the features of the application which you have specifically made for them, right? So if your API takes about 1 second versus 100 milliseconds, so users will feel that difference immediately. So making our APIs fast is of utmost importance while trying to build scalable systems. Second is scalability. Faster APIs can handle more requests with the same infrastructure. So let's say that an API takes 2 seconds and another API takes 200 milliseconds. Then the infrastructure would be able to handle more API requests with the API taking 200 milliseconds, because it is taking less time, so it can cater to more API requests with the same infrastructure and resources, right? Now, like I said, reducing latency is not just about speed, it's also about efficiency and cost, right? So it is important. Another point is that having low latency in real-time systems is very important, because every millisecond in a real-time system like financial systems or chat applications matter, right? So having low latency on those applications matters as well. Now, where does latency come from? So, as I said, latency does not come from a single source. It is usually a combination of multiple sources, and it's our responsibility to identify those sources and try to fix or improve upon those accordingly, right? Now let's break it simply, right? So it could be, firstly it could be database calls, it could be external API calls, it could be caused due to processing logic, and it could be caused due to data transfer. So there are many possibilities of why it is taking so much time. Now, even like, let's say even saving 50 milliseconds in 4 places gives you a 200 millisecond improvement, and that basically compounds over time, because like as the number of API requests improve, those 200 milliseconds also begin to matter as the number of users and API requests increase, right? So let's look at some principles to deal with this, to have low latency APIs, have better performing APIs. The first principle is to measure, right? So it sounds very simple. Let's measure the API cost, right? So one of the biggest mistakes engineers make is to optimize without measuring. Always measure before optimize, because measuring can give you insights into how you can further optimize your systems. Now you can do that by using telemetry and tools like new Relic, observability as well, right? You can focus on the P95 and P99 latency. So 95 here means that how much time is being taken by 95 percentile of the API requests, right? And same is for P99, so it is 99 percentile of the API requests. The second principle is to optimize our database access. So the common issues are basically n+1 obviously n plus 1, then too many queries, too many unnecessary queries, too many joins, missing indexes, and so on. So at the database level, we should try to optimize our queries and use indexes so that our APIs become more efficient and faster, right? And database are often the slowest part of the system, right? So, like, we should try to keep the reads and writes as minimal as possible and focus more on efficient queries. Okay. Then reducing unnecessary work, right? So one of the simplest ways is to improve performance by doing less work or unnecessary work. So what does that mean? That means that don't fetch unnecessary data. So if your, for example, if your front end page requires X amount of data, and you are sending, for example, 1.5x amount of data, so that 0.5x amount of data is extra data which is going through the system and is unnecessary. That increases load on our infrastructure and also increases the latency. Now these changes might seem small at first, but at scale, when we have multiple millions of users and are dealing with millions of API requests, then these small things begin to matter, right? The fourth principle is that we can use caching, right? So for example, a popular tool that we use for caching is Redis. So that is basically an in-memory data store, and caching can be at multiple layers. So it can be at the client side, the server side, or in between the network calls, right? So what caching does is that it stores the most frequently accessed data, right? So for example, one of the examples I've come across is that, for example, we have to show the list of cities in a country, right? Now the list of cities doesn't change that often. Like, it would be changing like in a year or two if it has to change. So it usually doesn't change. So we can just store that data in the cache instead of the database, and quickly just give the response accordingly, because querying for the same data which is not changing again and again doesn't make much sense. And when, for example, our cache is full, then we can just use one of the cache eviction methods, like first come first out, or least recently used request, etc., right? Now if the same data is requested multiple times, instead of hitting the database every time, you store it in memory. And to be on the sure side, we just add a TTL, or basically how long does it take. TTL is time to live. So how long do we have to keep it in the cache before refreshing it? So we can either use TTL or cache eviction methods, whichever is more suitable. The fifth method is parallelizing work. So, for example, in Golang, we have the concept of Go routines, and we can just use multiple CPU cores to perform the task parallelly, and also use threads as well, so that we can perform the logical operations in a lesser amount of time, right? So instead of doing everything sequentially and waiting for the previous step, we can do things independent operations parallelly, right? So for example, if you have 3 independent API calls and each takes 100 milliseconds, then sequential execution will take 300 milliseconds, which we don't want, right? The sixth principle is optimize network calls. So your network calls are expensive. Every external API call which you are making is adding to latency. So try to minimize the external dependencies, add timeouts, and avoid blocking calls, right? You should treat every network call as a potential bottleneck. Another use case which I figured out using experience was try to reduce the payload of your API, right? The payload size of your API, because having a large payload in your API request is not efficient, because the processing of that payload is going to take a good amount of resource and time. So we should try to break those payloads down into smaller parts, right? So like it takes longer to send, it is longer to parse, but we should try to send only required data, use pagination, and there was one more thing, enable compression, right? So we have to enable compression as well. Now let's go to principle 8, which is infrastructure optimization. So we can just improve our infrastructure and deploy on an efficient server, right? So a good infrastructure means that the system can handle load and have good low latency APIs, right? Now this is all and good. Having low latency APIs is like very good, and we also discussed what is like what things we can do or what actions we can take to make those APIs efficient. But whenever we are scaling a system or designing a system, we should always look at the trade-offs. So whenever you think of using one of these methods, then always think of what trade-offs this system might face. What are the potential failures which I might get, right? So some of the trade-offs you could look for is that if, for example, you are using caching and your data is changing a little faster than you expected, then the user, when they make a GET request, they would be uh, getting stale data, which we do not want to risk. Another thing is that with indexing, there are slower writes. So, whenever designing a database, you should always take that into account. And when dealing with parallelism, it can become complex at times. So, that is also a trade off we should consider, right? So, that's all I wanted to consider in this video. If you liked my video and thought that my video was valuable for you, then please do consider subscribing. It motivates me to make more such videos and content. So, to summarize, low latency APIs are not about writing faster code, they're about designing faster and smarter systems.